Hey, manufacturing world, welcome to another episode of Shop Matters, sponsored by Okuma America. I'm your host, Wade Anderson, and joining me here in the studio in Charlotte, North Carolina today, I've got Rocky Helms from Richard Childress Racing and Tom O'Toole, one of our Okuma brethren. Welcome, guys.
Oh, glad to be here.
All right. So, Rocky, why don't you just give us a brief introduction?
I'm Rocky Helms, Vice President of Manufacturing at Richard Childress Racing. I've been there going on 23 years. Came from another Cup team prior to that, manufacturing background prior to that, all the way from high school. Went to college for machine tool technology and got in at a RCR really at the perfect time when they were getting ready to ramp up the Okuma partnership.
Excellent. I don't know that I knew you were a vice president.
That come about in the last month.
Oh, okay. Well, congratulations.
Yeah, thank you.
That's awesome. Tom, how about you? Tell us a little bit about yourself.
I'm a double column product specialist at Okuma, so I support the dealers and my coworkers on the large bridge mills, our large product and our large VTLs, and that's the day job. And other than that, try to support Richard Childress. We go back quite a ways now, 20-something years now.
Yeah.
That we've been associated. So I was fortunate to be involved in it from the ground floor from day one. And it was really nice to see that grow over the last 20 years.
Yeah. So talk me through a little bit about how it got started. You know, my understanding, Waddell Wilson and Freddie Wilson were kind of the catalyst of getting Okuma introduced into it. And people who don't know or may know Freddie from the industry, Freddie Wilson's been with Sandvik for, I don't know, over 20 years and is still our Sandvik OEM rep at Okuma. So tell me a little bit about how all that kind of got started.
Well, Freddie was pretty instrumental in getting Okuma involved, or at least bringing it to our attention that NASCAR would be a good avenue to promote Okuma products. So that was way back at the Larry Hedrick 41 car that he was at, and Waddell was there. And then later they moved to the 17 car, and our participation moved as Freddie moved.
Oh, okay.
He would just badger the heck out of us until we went with him. So,
yeah. So Freddie was a machinist back then, right?
Yes.
Okay.
Yeah. So, of course, you know, Waddell is legendary in the industry, and Freddie's brother Greg is an engine builder and was there at the time, and as well as Freddie running the machine side of it to support the engine program and the car bodies.
All right. So, Rocky, tell me a little bit about how did we get involved going from the cars that Tom talked to joining up with Richard Childress?
So I had gotten there towards the end of 1999, and it's kind of a weird story. So came there as a machinist and fabricator on what was going to be a new Xfinity series at the Busch Series at the time, Xfinity Series program. And our normal HR manager, this is how much smaller Richard Childress Racing was back then. The normal HR manager was out that week on vacation. So the vice president of the company, which was Bill Patterson, and Bill Patterson was very instrumental in all this also. He done all my paperwork for insurance and, you know, all the new hire stuff. And I'm filling out a resume so that they have something on file. And he noticed that I had a lot of manufacturing background and experience. So he asked me if that was something I was interested in. And actually, lo and behold, that was the whole reason I came there. Was during my tour, it was one of the few race teams at that time that had any type of CNC technology. And at that time, they still only had two, and they were part of the engine or research and development part. And all they'd done was strictly engine parts, and it was only a couple of things. So he told me they were working on something that he couldn't really say what it was because it hadn't been announced yet, but that he would keep me in mind if that was something I was interested in. So found out a few months later, Richard come and talked to me actually in the Busch shop, and told me that they were had been talking to Okuma, looking at a technical partnership. So we sat down and actually talked about what that was looking like, what it entailed. I sat down and talked with Spenny Clendenin and Steve Wilson, which were the ones that ran the engine shop, and they transferred me over to there. And that was when I found out kind of the backstory that they had been involved with the 41 car. And so Richard Childress Racing was looking at expanding their machine tool technology capability and manufacturing, and decided to partner up with someone that not only, you know, from the machine side, but the big thing with Okuma was also the application side and help in general with, we were going to be going from doing some cylinder head machining and intake manifolds and a little bit of piston modification to trying to produce more of the car in-house, billet spindles, Centerlink suspension components, more engine components than what we had been doing as far as rocker stands and rocker bars and motor plates and a little bit of everything. They wanted to bring more in-house. So we felt like with Okuma and the expertise Okuma had with the application side and being able to utilize that was what led us to get in touch with Tom O'Toole and all the people at Okuma and try to make something happen.
Okay. So Tom, tell me a little bit about your role. How did you get involved on the race car side of Okuma's ventures?
That's a really good question. I don't recall exactly.
Just drew the long straw.
I believe John Hendrick probably said, "Do this."
Yeah.
And,
so you did that.
Well, I was always kind of a motorhead. So as Childress was pretty small, so was Okuma back then.
Right.
We wore a bunch of different hats. And, if you're in engineering, you may help on a project and then you find yourself installing the machine as well back then. And
right.
So kind of fell into it that way. But RCR was the first program we did that we really laid out, like Rocky said, the parts that we wanted to do. We did a matrix and looked at the cost of the parts. Why make a 10-cent part in the house? Look at the more expensive parts, the more complicated ones, the ones that could be improved. It wasn't just all the engine stuff, but a lot of chassis as well.
Okay.
So it was a learning for both of us. And when we started the program, I guess some of the parts we looked at were kind of what you consider commodity, just usable stuff that making it in-house had its own advantages. And then we spent a lot of time working on like R&D type stuff. And that's what Okuma really brought to the table is, some lathes and mills to make the commodity stuff. But then when we got into cam grinding and piston turning back then, nobody was doing that in the industry, making their own.
Right.
And in fact, if you recall, you had the one-of-a-kind piston turning machine, the only one that existed like that.
The V8 cam lathe. Wow.
Yeah, we could tilt the turret to camp the ring grooves on the piston, which nobody did at that time.
Yeah.
So, we're doing a lot of things back then that were unique. So.
Yeah, we were the first and still only team to do their camshaft manufacturing in-house. And that wasn't something we even thought about until partnering up with Okuma. And there was a huge advantage to the camshaft side with longevity. At that time, a cam was one race and done. And our engineering department on the engine side, had some materials and stuff that they wanted to try, but at the same time, you don't want to go to, just a camshaft manufacturer and say, this is what we want. And it may make its way out into the rest of the world.
Right.
So we started out with a lot of R&D camshafts. Once we got the Okuma cam grinder, we could spool up and make our blanks and then rough grind them, leaving stock all the way around. And then at the drop of a hat, within 30 minutes to an hour, we could grind something special, put it in an engine, put it on a dyno, try it out, see how it was, and make some slight changes and put another cam in. And, within a few hours, we could be back on a dyno with a whole different profile.
Wow. That's interesting.
Right. And back then they were, the cams were all hardened.
Yeah.
With Stellite, I believe. So we
Wow.
had, I think I still have blanks in my garage of the Stellite blank cams that are still sitting around.
They went from 500, 600 or 700 miles on a camshaft into the 6,000 miles.
No kidding. That's incredible.
Yeah.
All right. So let's talk through the technologies. What was the first machine that I guess, Tom, that you worked on, or the first machine that came into RCR?
MX-55.
MX-55 vertical. We did pistons on it.
Yep.
Okay. And you worked on that machine?
Oh yeah.
So you're not just big machines. You actually did small machines back then too, huh?
Oh yeah. Yeah. I wore a bunch of different hats. So they weren't ready for a double column yet at the time. So you just had to go with what we had.
Right.
But we laid out a complete shop layout. Steve Wilson, at the time, we had with the building that we had, we had a whole vision of what we wanted to make. So that was my earlier comment about the Matrix, is that really drove what machines they got. Remember at the time too, engine blocks.
Yeah.
It was almost impossible to get a quality machined engine block at the time. So
that was when we got the MA50, the
Yep,
horizontal.
the horizontal.
And we started doing all the manufacturing of our engine blocks. We were just getting a casting with some roughed in stuff. It'd be decked and some rough bores and stuff like that. And every engine manufacturer was doing a lot of customization. Piston oilers on the bottom, you're doing machining on the pan area, lifter bores, boring it for sleeves. That was when we started doing sleeve blocks. A lot of just customization of the machining away from just a standard block that was coming from GM.
Yeah. Okay. And that's all cast iron?
It was CGI, compacted graphite.
Which was an event. CGI was an event in itself.
Yeah.
It's a material that contains a kitchen sink and everything else I think they can throw into it. Insert life was minimum.
Yeah.
Tool life challenges.
Yeah.
And
A big one for us was cylinder heads also. And we worked with Okuma. They had the PM600 Cosmo. Worked very close with them on developing a process to do cylinder head machining with that machine.
Yeah. So that was the first machine that I saw at Okuma when I first hired into Okuma. Actually, I might have saw it on the interview when I was interviewing, and they walked me out on the shop floor. As you walk out into RDT, it was sitting right there on the right. As soon as you walk out, on the ball screws
and you
sticking
didn't run
out
away.
of the roof. No, I didn't run away. I should have, but no, I'm just kidding. But that's an interesting machine. So anybody that hasn't seen that machine, what Rocky's talking about, the PM600 was like a hexapod machine. So the spindle is actually supported just by the ball screws. So there's no linear X, Y, and Z. Everything is in the ball screws on the spindle, which made it a very fast machine, and you could articulate it very well. So you guys had machine number 1, and then machine number 2 was on the floor when I first started at Okuma.
Yep.
And then eventually you got machine number 2, and those, to my knowledge, are the only 2 in the United States.
Yeah.
Yeah, that'd be another example of, RCR has some pretty unique technology from us.
Yeah.
And those machines have been up there for quite a while now running.
Yeah. The first one came in 04 and the next one in 07.
Okay.
And they still run 24 hours a day, 5 days a week. And when we go home on Friday, we load another cylinder head in each one.
Yeah. Wow.
They run a lot.
I remember the first time I visited RCR, the motor basically on the end of the ball screw, as it swung past, there was a rafter in the ceiling. And if I remember right, it was like positioned in between the rafters.
Yep.
So it would actually pass through it.
Yeah,
so
we had we notched out the drop ceiling to make clearance for them.
Yeah. That's interesting.
Well, that building's grown quite a bit then, the size. I mean, where we started out originally.
So is that in the same building, or is that a different facility?
So when I went there and done my tour, like I said, it was at the back of the engine R&D department. They were in just it probably wasn't a 30 by 40 room with 2 machines crammed in there, a horizontal and a 5-axis. And when we got the Okuma deal, they were going to give us our own building. So it was right straight across the road from the R&D department, but we were also going to merge it with engineering. So it was going to be a full captured shop of being able to do everything. We were going to have our engineering department. And like Tom was saying, part of it was branching out beyond just engine components and starting to do chassis components. At that time, when I went there, we were purchasing a chassis, which every race team was for the most part. They were buying either a Hopkins or a Laughlin chassis. And then they were buying their spindles and their center links and idlers and pitmans and rear end housings and trailing arms and all that. So Richard had the vision that we want to branch out and start doing more stuff in-house for 2 reasons, not just because you don't want your concept or your idea to get out, but also the big one is the turnaround time. That's the main thing, is most machine shops are going to be 4-6 weeks. If you took an idea to somebody and said, I need this new spindle or whatever, you're going to be 6 weeks. Well, that's 6 races.
Right.
And, at that time in a 32, 34 race schedule, that's pretty big. If it's going to take 6 races to get something new, they want to be able to do it in 1 to 2. And most of the time it's 1.
Right.
It's Monday morning. This is what we want. And we want it on the car Thursday to go to the track.
Right.
So that was probably the biggest driving force. And that was where Okuma came in big time with Ron Ronaszewski was our main contact on the mill side.
Yeah.
And Rick Kimmons on the lathe side. So, you know, I remember Ronaszewski coming up the very first week the MX-55 hit the floor and giving us all training. And, you know, they helped us out a lot with getting going early on. We had taken an engineer, Clifton Kazai, and moved him over to program.
That's
and
right.
you remember Clifton?
I remember Clifton, yeah.
We had Clifton and Savon. Savon was doing our 5-axis, and Clifton was moving over from the engineering side in the engine shop to start programming. And then we'd hired Mark Osborne had come on to help manage it and oversee it. And that was the big thing, was bringing a lot more stuff in-house to be able to turn it around real quick. Mm-hmm. And, you know, like I said, they'd come on Monday and want something in a few days. We had the building with engineering in the front, and we got the back half. So we crammed 5 machines in there. We had a MX-55 and then a Cadet 40-20 vertical. And then we had an LB 200 and an LU 15.
That's
two
right.
lathes, and then we brought the MA 50 in. We got rid of our old horizontal that we replaced the MA 50 with, and then we still had our 5-axis that we had before the Kuma partnership until we found something that could do cylinder heads. I mean, they had 5-axis machines, but they were bigger,
right?
And we didn't need anything quite as big to do a cylinder head. But to answer your original question, we were just the back half of that shop. We probably didn't have more than 2,500 to 3,000 square feet of it.
It was tight.
And engineering had the front.
Okay.
And at that time, we were rotating machines out probably every 4 to 6 months. I mean, we had 2 or 3 LU-15s. A customer could buy a machine from our floor.
Okay.
Right.
We had, and then the LU-15 V8 cam came in.
Yep.
So as we got the ball rolling, it didn't take long to realize, man, we can get some cool stuff done pretty daggone quick.
Right.
And then we just started adding more machines. We got another lathe or two, and then we got the PM600 came into play, working with Kevin Krajewski and a bunch of different ones at Akuma, Ronaszewski. They come up with the concept and worked with us. We also worked with our PTC on the post side of it, developing a post, and moved the cylinder head manufacturing over to the PM600. The best I remember, that machine was actually on display at the PRI show that year in 2004, and I think IMTS as well.
Mm-hmm.
Yeah.
And then once it left the shows, it came to our facility, and we kind of outgrew it at that point. So the partnership started in 2001. By 2007, 6 years, engineering had moved out, so we had the entire shop, and we still had outgrown it. So we went from the back of the shop to the entire shop to moving to the current facility that we're in, which was probably about double the size. And then just a few years ago, we added another 5,000 square feet onto that.
Yeah.
We've added a second shift. Now we're up to 21 machines, and about 32 people on 2 different shifts. And now we've outgrown that.
Yeah.
Again.
It's grown. And back then, that was before you had the really large building that you have now. So it consisted of a bunch of smaller buildings that were spread out.
Okay.
So you ask how I lost weight. A lot of it was going up the hill to the 3 shop because nothing was close to nothing. We had R&D across the street.
Yep.
That was okay.
Yep. They built the chassis shops. Yeah. When we started doing all this stuff, they just, started doing their chassis in-house. So a whole new facility got built for chassis manufacturing.
But it couldn't be any further away from the 3, where the chassis shop was all the way on the far end of the earth.
Yeah.
And they built a new engine shop for production. So we had the R&D engine shop and the production engine shop.
Yeah. Okay.
And they started taking on alliances. And, we were at the height, we were building about 650 engines.
Okay. And Tom, your office was up there, right?
Yes.
You were stationed there at RCR full time?
Stationed out there just to support and help it grow. Like Rocky said, there were a lot of irons in the fire of different things we were doing back then. So, I was up there pretty much full time. And then, of course, you'd reach out to your coworkers whose level of expertise, like Rick Kimmons was the guru on piston turning.
Right.
He knew how to program the machine to adjust the ovality And
he
so
was the cam turning expert.
yeah.
And it's fun for me to, as you guys are throwing all the names out. Rick is one of our main instructors over the training program at RCCC, the college that we deal with. So he's still tied in with us. You mentioned Ron Ranishevsky and Kevin Kraske. These are still active.
They're still around.
Still working.
Rob
with
Titus
us. Rob Titus
on the cam grinder.
Yeah, he done all the cam grinding stuff.
Right.
And Kevin Kraske's actually been heavily involved in our latest venture with the Multus, with the B250 Armroid machine, getting that up to speed with the new hub nut for the next gen car.
Yeah. So how have you seen manufacturing really transition from where you started in the early days of the relationship to where we are today?
Definitely one of the big things is the technology that we've got. I mean, we started out with a 3-axis mill with a rotary, a 4th-axis rotary for doing the pistons, and a horizontal, and some 2-axis lathes with live tooling to, our latest machines is the Multus U4000 with the full 5-axis, and the Armroid, the B250.
Yeah.
Both of those are two of the most technologically advanced machines that we've had in the shop.
Right. So the Multus U4000, that's a big mill turn machine. What type of parts do you do on that?
A little bit of everything. I mean, we've got some small parts that we do on it, some oilers, because they have angled holes and stuff. We've started branching out. One of the things we started about 4 or 5 years ago was branching out into contract manufacturing beyond just the racing stuff. We've got some military and defense type parts that we're doing on it. One of the main things that we utilize it for was the camshaft manufacturing. We had been doing that on an LU-15 and then an LU-300 later, using the upper and lower turret, pinch grooving, pinch turning, and tailstock. When we had to send it out, we'd send our camshafts up north to a gun drill manufacturer contractor to have the centers gun drilled. It was like a 1-inch diameter hole, about 20 inches deep. Once we got the Multus U4000, it has high pressure coolant and everything. We actually do the gun drilling on the machine and do all of the turning and stuff using the sub to pull it out from the main, and then working up against the chuck. When we first started doing the camshaft manufacturing, at that time it was a LU-15, and we were new to it, so we were not being overly aggressive on speeds and feeds and all that until we got more familiar. The camshaft was about 2 hours and 45 minutes, a little bit less than 3 hours. Now we're right around 25 minutes.
Wow.
So
that's incredible.
Yeah. And a lot of that was with Kennametal helping on the tooling side, and then with Akuma helping on the application side.
Mm-hmm. Okay. So, Rocky, the Multus B250 that you guys recently took possession of, that's got a built-in Akuma robot inside. Talk me through a little bit. How does that integrate into your production, into your manufacturing?
Yeah, so that's been a new one for us. Definitely, I've wanted to kind of get us into the robotic side and stuff for a couple years, and then when Akuma came out with this line, the Armroid and the Standroid with the vertical stuff, reached out to Akuma about trying to get us into the automation side a little bit. So we had won a contract. A lot of people, especially if they're familiar with NASCAR, knows that in the last couple of years, there's been a transition to this next gen car, which ironically is almost back to the way racing was 20 years ago, where more things were purchased. So there's single source suppliers for your suspension components now and stuff like that. Now the engine is still specific to the manufacturer, so everything we've done engine wise, we're still doing. But on the car side, you've got a single source supplier for your transaxle and for your suspension components, your chassis. We can no longer build our own chassis in-house. So that was another reason a few years ago we knew this was coming. So we have 21 machines and 30 some people and all the technology we need and experience to do basically anything. So we started looking at how are we going to keep everybody employed, but there are still over 200 part numbers that you have to manufacture in-house. So we still need the resources we have for the engine shop and for parts of the car, but we try to offset the cost of that by doing contract manufacturing also. So we actually built the very first next gen car. NASCAR contacted us, or basically we were contracted to build the first one. So that was a major undertaking, and without Akuma and their support and everything we had, it would have been impossible. From the beginning of manufacturing to the car being on the track was about 7 to 8 weeks.
Wow.
And that was for a car that had never been built. We had to build the fixturing. Dallara was contracted by NASCAR to design the car. So we did receive, the designs, but as far as manufacturing, and it was a total effort of everybody at RCR, the chassis shop, they had to do everything. And then we had a whole team that basically worked on nothing but the next gen, working with Dallara. There was a lot of design changes on the fly, and working with Brandon Thomas and the group there at NASCAR. So we built the first car, and then found out that the way NASCAR was going to do it is these individual assemblies and parts and components were going to go out to bid. So we actually bid on some of those and won some contracts. So we're the supplier for some of the next gen parts to all the teams.
Okay.
So that was we realized that we're going to get into more automation. We're not just making parts for us now.
Mm-hmm.
One of the contracts we got was the single wheel nut. That's kind of been a big topic because it's one of the biggest differences between the car last year and the car this year is instead of 5 lugs, there's one single lug.
Right.
We got the contract for that and realized we're not just supplying that for our team. We're going to be supplying that for 40 plus teams. So it's not going to be something that changes every week like everything else we've made for the last 20 years. Spindle this week is not we always joke it's the spindle of the week. I mean, every Monday it was, we need a different spindle. This we need this caster and camber, and we need this ball joint location. So now we've got something we know we're locked into on design for 3 years. We know kind of how many teams we have to support. And once we get into the racing, we can determine what our usage is going to be. That was the main driving force with trying to get something that was automated in, and it's worked great. The Armroid machine, we just load the stacker with slugs, and we've got 2 options right now. One is doing just the turn portion on the Armroid and actually using the PM600 5-axis for doing all of the pockets and all the 5-axis milling. Then there's another option, which is the entire finished part on the Armroid.
Okay.
Obviously, the total throughput to get parts out the door is faster to split it up.
Mm-hmm.
But then if we have a little bit more time, then we can do the whole thing on one.
Yeah.
And it's just loading the slugs. It's, we've got it's got the collision avoidance on it, which is how the whole system works basically with the robot. And then we've got the tool breakage and tool wear and all that stuff. So we know what our tool wear is. We know how many parts we can run. And then it's got probing on it also. So we can measure the parts on the machine, make offset adjustments. Like without Kevin Krajewski and other people at Akuma, we would not be anywhere near where we are on getting up to speed on it.
Oh, that's awesome. So tell me some stories on Tom from Tom's time back at RCR. Tell me some dirt that we can use to give Tom a hard time about.
I know there was one where he about blew up his neighborhood.
All right,
with some gas and maybe some beer was involved. And
all
right, Tom. So talk us through that. What happened?
I miss carburetors. That's what I miss. I'd like to get back to those days when we were machining parts like that.
Yeah.
Yeah, you was there for some of the carburetors at the last minute, staying all night.
Oh yeah. That was a lot of work that went into them, manifolds and things like that. That I think Rocky said now you got to buy the parts, and I've still got some old 350 Spiders sitting in the garage, and I don't know where they came from. They just
well back then
showed up in your lunchbox one day?
Yeah.
Well, back then, like I said, we were changing something every week, and the little change. One thing we were doing was like header design. When the header design would change, it would change where the starter needed to be. So I don't know if you remember, but one of the early parts that we were doing on the verticals was starter housings. We would buy a starter, AC Delco starter, but take the housing off and make our own so that we could relocate the starter in a different spot so that you could clear the headers.
Okay.
So, something you wouldn't think would even matter that much. Oh, you just put the starter on. But when the header design changed, then that's going to dictate where the starter needed to be. And it was stuff like that. I mean, we made like 5 different versions of just the starter housing with different, where it would locate it in a different spot.
Yeah.
the parts were just, especially on the car side. Once we got the engine side, has always been a more, I don't want to say planned out, but they'll put together a build schedule and a testing schedule and stuff like that. And the car side, on especially the chassis components and stuff, is every single week everybody's moving the needle just a little bit more. So you're trying to come back with something that is a little better than what you had the week before. And
Right.
and that's usually been the biggest hurdle, is the timeline that you have to try to get something done.
Sure. Well, Tom did a great job of, as a true sales guy, deflecting the story
Diverting the
from his. So we'll keep blowing up the stump for another time. So, well, Rocky, as we talk about contract manufacturing, if somebody wanted to get in touch with you guys to look at doing manufacturing work for them, how do they reach out to you guys?
Yeah, we actually have a website, RCR Manufacturing Solutions. You can go on and Google us or anything, or get in touch with me as far as email and stuff like that. rhelms@rcrracing.com.
Okay.
Reach out to us. We also have a guy that's vice president, VP of business development and stuff, Mike Brown, that handles actually the technical side of that, with getting customers in the door and stuff, and handling all that.
All right. Excellent. Well, guys, thank you for joining me today. I appreciate your time. And thank you for joining us. If you have any thoughts, questions, ideas for future podcasts, please reach out to us. Otherwise, till next time, we'll see you then.